Alright. I think we're live. Audio check. Let me know if the music's too loud or if my voice is not coming through well enough. Drop the music a tad. Yeah, we'll get started in just a second here. Check, check. Looks good on my side. I'm a bit quiet. Okay, let me just pull this mic in closer. Actually, I can boost my sound here. Check, hello, how's that sound? Okay, I'm stoked on this one. This has been a long time coming. But there's a lot of prerequisites to Lightning Address, and honestly, even though we've gone over them in the past, and I've talked about them at length, we're still going to go through them again, because it's kind of, Lightning Address is just built on this spec that we can't really ignore. We need to implement it and understand it in a basic way. And then once we get to the actual Lightning Address part, surprisingly simple. So I had a lot of fun putting this together. It should be a bit over an hour, but I lined up all of these slides. So let me go ahead and show you over here. This is the link to the slides and the completed project. So you'll want to get these slides up on your side if you're following along. The slides have all the code and just everything that we're going to go through. It's all going to be done in order. And I'm going to do it all from scratch along with you. So if something's broken, then I will find out along with you. But hopefully not. Tested it a few times. But yeah, so tinyurl.com/lightning-address-workshop. So you can find that. And then it's next lightning address is the repo name that I'm on my GitHub. And that's the completed project, so we're just going to essentially rebuild that completed project exactly as it is. But the completed project is live right now. It works. I have a very janky Lightning address that completely functions, has kind of a funny name, and we're gonna build that ourselves. And what's really, really cool about this setup is that if you have your own node, you're running your own Lightning node, and if you are able to connect to it, then you can host your own Lightning address for free with Vercel, essentially forever, with no cutoff, using NextJS. So we're gonna go through that. I think it's a kind of a cute trick we can do nowadays, a shortcut to just running a full server and hosting it and paying for it and dealing with all of that. And so we'll get into that in a second. First, I just want to show you what is this. This is Plebdevs. So Plebdevs is a community of developers, mostly beginner developers, we're all learning to build on Lightning, learning to build on Bitcoin. You can find out more at plebdevs.com. We've got our 2 courses right here. This Lightning Wallet front end, this will give you the basics to just learning how to code at all from the very scratch. You'll learn some web development fundamentals, and we'll finish with actually building a simple Lightning wallet. And the backend course I just released about a month ago, that picks up on the first course, and we take our knowledge into the backend, and we become full stack devs, and we build a full stack Lightning wallet with our own node. Very cool. So we've got the courses. You can join the Plebdevs community here. It's on Discord, and then all of our workshops are on our YouTube. This will be uploaded to YouTube at the end. Sweet. So with that, let's get into it. So once again, these are the slides and the completed project. I'll probably have to go back to this if someone joins late. But let's jump in. We'll talk about the prerequisites, what you need to kind of follow along. So basic knowledge of JavaScript. We are going to be writing JavaScript with NextJS. Basic knowledge of Bitcoin and Lightning. There's a lot of details I'm just going to graze over that I'm assuming you know about how Lightning works. Just the basics of channels, liquidity, and invoices. What an invoice is. Basic knowledge of GitHub and a GitHub account. We're going to need this because we are going to build our project locally, and we're going to push it to GitHub, and then we're going to deploy it on Vercel, and we'll need a GitHub account for that. And then you need an L&D node of some kind. We can actually host a local reg test Lightning node, and I'll be using that first. We'll be developing locally, and we'll run a little Lightning network environment locally. And then once it seems to be working, we're just going to go rip it in prod, and I'm going to connect it to my own node. So that should be fun. Okay, cool. So this is what we're going to cover. What is LNURL? What does LNURL pay? Actually, pause. Hold that thought. Let me jump over here. So on our Plebdevs YouTube, I did a workshop maybe a month ago. That was LNURL pay workshop. Yes, so this is kind of the prerequisite workshop, I guess, to this one. We learn about the base spec of LNURL and how to implement the pay spec of it, which is essentially what you need in order to do Lightning address. So I highly suggest you watch this, but also, honestly, like, I know that a lot of people are joining the first time, so I'm going to go over some of these LNURL spec details. We're just going to go through a little bit quicker this time. But of course, if you have questions, you can hit me up on Discord, throw some questions in the chat. And yeah, that should be good. Cool. So I'm going to talk through what is LNURL, LNURL pay, then what is Lightning address. These three things are kind of a stack. These are technologies that are stacked on top of each other. We've got LNURL at the bottom, which just runs on a server, just an HTTP server. LNURL pay, and then Lightning address sits on top of that. We're going to talk quickly about what NextJS and Vercel are. We're going to set up our local dev environment, and we're going to build a Lightning address server. And then we're going to connect to our Lightning node, and of course, test and prod. So let's get into it. Starting with what is LNURL. Okay, so LNURL, it's a protocol, it's a set of standards. It connects Lightning wallet functionality through an HTTP server, which allows for easier integration of Lightning payments into apps. Using Lightning can be this multi-step process a lot of times. So really, a lot of what the LNURL spec is doing is trying to simplify that into a QR code even. Like here, where I should be able, if I want to pay you, I should be able to just scan a QR code, a static QR code that you can host. It doesn't need to change. That way you can just post it and ghost it, and then I can always pay you to that. Versus the traditional flow where we have to kind of go back and forth, and you have to pass me an invoice and I have to pay it. So LNURL, it's essentially a domain endpoint that is encoded with Bech32. This is just encoding we use in Bitcoin a lot. Yeah, the same encoding scheme for SegWit addresses. The protocol, it's an open source project on GitHub. As of this date, it contains 20 documents, each of which are called a LUD document that describes the different pieces of the protocol. So a LUD is kind of like a BIP, or a NIP, or a BOLT, or whatever your favorite acronym is. So let's just hop over real quick. We're going to go into the spec, and we're just going to graze over it. We're going to start with LUD1. This is the base LNURL spec. So what does it tell us? It tells us that LNURL is a Bech32 encoded HTTPS onion URL that can be interacted with automatically by a wallet in a standard way that such a service can provide extra services or a better experience for the user. So long story short, this is just a scheme, a protocol that we follow, a set of rules that we follow, that we host on a server, to where that server is able to interact with our wallet and pass invoices and do other things. And then an app or a user, whoever else, can interact with that server to send us money, to open channels with us potentially. There's actually a lot of functionality in the LNURL spec that we're barely scratching the surface on. So it's pretty cool. So what is this Bech32 thing? So we take this URL, you might have, this might be the URL to your server, and we just encode it in this Bech32 format. And we're able to present it as a QR code or just the raw Bech32, and then that gets decoded. And when that gets decoded, it will have information about how our LNURL server can be interacted with. And for right now, that interaction is going to be very simple. It's just going to be, you can pay us and here's the format in which you pay us. Cool. So that is LNURL. You know, we're hosting a server using a certain format, and we Bec32 encode it. Yeah. Cool. So why LNURL? So payments without interaction, as is the TLDR. There's a lot of other reasons. Like I said, there's many features that LNURL can give you. But, you know, traditional payment flow here, I want to pay you 100 sats. You generate me an invoice for 100 sats. You send me that invoice. I pay the invoice. You verify that it was paid. This is a lot of interaction, right? We're having to manually do this in the middle of our busy day, and it adds a ton of friction. Versus the LNURL payment flow, I want to pay you 100 sats. I scan your LNURL with my Lightning wallet, your static QR code that you generated maybe a month ago. I can set an amount I want to send you, and then I confirm and I pay you, right? So it's all on my side. You don't need to interact in order for me to tip you with Lightning. And then, of course, if you're familiar with Lightning Address is the ultimate version of this, where we have this easy-to-read address that essentially replaces this QR code. So that's kind of what Lightning Address does to extend onto the LNURL spec. We take what would be kind of a QR code format and we just move it into an email address type of format. You could really think of it as simple as that way. Cool. So problems that LNURL and LNURL Pay solves. It's easier interfacing of node functionality with apps. We're abstracting the node's interface for public interaction, right? For tipping. You don't need to know, you shouldn't need to know the LND API in order to like send me a tip or something like that. Allows for setting an amount at the moment of payment. It enables us to have a static QR code for receiving while still generating new invoices for each payment. So that's the big advantage right there. And then it enables human readable Lightning address, of course. Cool. So we talked a little bit about LUD1. I'm just going to graze over this. We talked about this. Enables interactions between a wallet and a service. Promotes additional services. Okay, this is just about the formats. They can be all uppercase or all lowercase. Yep. Okay, and so the other thing I didn't mention is that LNURL has these tags, these tag query parameters, which hold a special meaning, and the actions depend on the tag value. So the tag is basically just broadcasting. This is what features the server supports. Do you want to pay me? I support pay, right? And this is essentially the full interaction right here, like where we have maybe this is my wallet. I want to tip you. And so I scan your LNURL, and I get this URL, and that sends me to your server. And then your server fetches an invoice from your Lightning node, passes it back, and then passes it back to my wallet where I confirm and can pay it. It's pretty cool, not too complicated. So LUD06. LUD06 is the pay spec. So we have the LNURL base spec. This is mainly just defining, remember, the structure of how we should communicate, how we should broadcast what we can do. And LUD6 is the actual implementation of a static endpoint that you can get invoices from. So we'll look at this in a second. So essentially, wallets can scan a static QR code or click a static LNURL to get payment details. These details may contain extensive metadata, more than a regular Lightning invoice, and then payment amounts may be fixed or range-bound. They're usually range-bound. Usually there's a minimum and a maximum. Let's look at LUD6 now. There's a few things in here. I mean, we could read through all of this, but we're actually going to be putting it into action. But very simply, for pay, what happens is when someone scans our LNURL, they get this object back, this JSON object, and that object has a callback. This is where they'll request the invoice from. It has a max and min sendable, so how many sats you can send to us within a range. This metadata is just additional information on here. We'll say, you know, this is Austin's LNURL server. And then the tag, of course, shows what kind of features we support. So being LUD6, this is the pay spec. This supports the pay request. So your wallet, you scan your wallet, and your wallet gets back this object. And then what it is able to do is it is able to call this callback with an amount. Let's see where that happens. Yep, here's an example. So it calls the callback with an optional amount. I know this format right here looks kind of funny, but we'll see it in plain text here in a few minutes. So you basically just say, okay, I'm going to go to your callback, and I'm going to say, you know, I want to send you 1,000 sats, and you'll get back this PR, payment request, which is just the invoice, which you can grab and then you can pay. And there's another additional step here that actually on the LNURL side, when we create this invoice, we don't just create it, we actually pass the metadata in as what's called a description hash, which helps the payer to verify that they actually paid us, because we're just sending them an invoice. They didn't know where it came from, right? So this is the part where the person that's paying us can verify that it came from our LNURL server, it came from our Lightning node. And so we'll see that in a few minutes once we implement it. But yeah, I mean, pretty simply, the user should scan it, they get back this object, and when they go back to the callback with an amount, we're able to give them an invoice from our node. So that is LUD6. So we have LUD1, LNURL. We have LUD6, the pay spec. And then once we have both of those pieces in place, we can take the more simple Lightning address format and bring that into the picture and build it on top of all of those. And then it all works pretty seamlessly and simply. So LUD6 payment flow. We kind of talked through this, but let's go through this diagram. So we send a request to the LNURL server. You know, this could be the scan. And then they respond with that object that has all the instructions and everything we need to know. We go to their callback with a payment amount, and then they create an invoice from the Lightning node, and they send us back that invoice. Boom. Not too bad, not too bad. But if you're doing it for your first time, it's easy to run. I ran into a few troubles, a few dumb moments. Okay, LUD16. This is Lightning address right here. Let's peek at this spec. So paying to internet identifiers, email-like addresses. And this is a pretty short spec. There's a lot of text here, but it essentially is just telling us here is the format of how you present your Lightning address, and then how someone takes that Lightning address and uses it to find your server, to find where they can get that callback and request invoices from. It's pretty simple. It's still that one-sided interaction. You know, me as the receiver, I don't need to do anything. I just throw out my Lightning address, and anyone can interact with it, and therefore interact with my server and get the invoices. So, so here's kind of a graphic from lightningaddress.com. So we get the domain from the LN address. We kind of pull it apart like this. So username @domain.com. We visit the domain. We put in this .wellknown /LNURLP/username. So that's kind of the format that we have to stick to. If we don't stick to this whole format perfectly, then when we try and scan it with the wallet's going to be like, wait, hold on. You know, you're changing the rules on me. I don't know what's going on. You know, cancel. So we have to follow the spec perfectly, and then, but once we do, we're going to be interoperable with every single wallet that supports it. You can put your custom Lightning address up on Nostr, and people can zap you. So it's really powerful in that regard. Yeah, so we request to this domain right here. We get our callback, which we've already looked at, or this object rather, with the callback in it. And then it says right here, the rest is the normal LNURL pay flow that is detailed on the LNURL specifications. So we know how that works already, but it'll make a lot more sense once we start to implement it. Cool. So I know I grazed through that pretty quickly, but throw in any questions if you have them, and like I said before, feel free to hit me up on Discord. And if you're following, if you just joined and you want to follow along, you need to find the slides here. The slides are at tinyurl.com/lightning address workshop. So you go to this and you'll get access to the slides, and that will give you the code, which will make it a lot easier to follow along. And this is also the completed project if you just want to skip to the end and skip all the explanation and see the code and run it yourself. Okay, so back to where we are. So now we're going to talk about our tools that we're going to be using to kind of build this and host this, and that is NextJS and Vercel. So NextJS is my favorite framework. I use it for most of the workshops, and I ended up explaining it every time, but essentially it's a React framework that allows you to build a front-end web application and a serverless API, allowing you to have your front-end and back-end all in one project. So what does this mean, serverless API? This is basically, it's a clever scheme to where you can host a server, but that server isn't always online. It only comes online once someone makes a request. Why does this matter to us? It matters to us because it's free. We don't care that it's serverless. It could be a server, it could be serverless. I'm pretty sure in our last LNURL workshop, actually, we made a real always online server. But with Next.js, we get this serverless API, which they let us host for free. And we essentially get the same capabilities as an always online server, because we only really need to be online at the moment that someone is requesting an invoice. Okay, so we're not even going to have a front end in this project. We're just going to have a serverless API. It's just going to look like a very regular API. And then we're going to be able to host that for free. And people will be able to interact with it. And Vercel is the web hosting platform we're going to use. Has a ton of cool free tier features, such as hosting unlimited front-end websites. You can host serverless APIs for free, as I was talking about. And they also have some free database options that could last a lifetime for most of your small projects. So they give you like a free tier database that has like, gosh, what is it, like 100 gigabytes or 1,000 gigabytes of storage, and it has all this compute time to where if you're just making your simple Plebdev project, it could probably last you for a very long time, and you can get that full experience of, you know, developing locally and then going into production without having to spin up AWS and not know how much they're going to charge you, which is always really stressful. So I like to keep stuff free when possible, so it's just another reason that Next and Vercel are pretty awesome. All right. Okay, so now we are going to start coding. We're going to start building our project from scratch. We're going to create a new Next.js app. Just so you know, if you don't have, you know, so you might not have Next.js set up. There's other tools that we're going to be using that you might not have installed yet. If you fall behind or something like that, that's totally fine. This is going to be recorded. The slides will stay live. And that's just the reality. I mean, we need to use these developer tools, but sometimes it takes a long time to install and to set up. So I know how that goes, but I'm just going to walk you through exactly what I'm doing and try and use as few of these tools as possible. So creating a new Next.js app, we can use this command npx create next app at latest, and it's going to give us a series of options that we're going to say no to most of them. No to TypeScript, yes to ESLint, no to Tailwind, no to source directory, no to app router, and no to import alias. What this is basically going to do is this is just setting us up a basic project template of a Next.js project, so we can dive right in and start writing code that runs right away instead of needing to set up all these configurations and yeah, that's no fun. So I'm going to open up my terminal and let's get this going. So I'm going to do npx create next app at latest. And it's going to ask for project name. Oh, I spelled this wrong. Create. Okay, it's going to ask what I want to call this project. I'm going to call it Lightning Address Workshop. Cool. TypeScript, no. ESLint, yes. Tailwind, no. Source, no. App router, we're going to say no. And then the default import alias, we're going to say no. And this will just give us a very standard, simple NextJS app setup. We'll take a second to spin everything up. And then I'm going to open this in my code editor, which I use VS Code. Looks good, so I'm going to go to my desktop here. We have Lightning Address Workshop. I'll pull it over here to Visual Studio Code. Okay. Cool. So this is our empty project that we start with here. We're mostly going to be in pages inside of API, actually. And next, we're gonna create the structure for this app. Actually, first we're gonna install the required packages. So I'm gonna copy this command and I can run it inside of my project. We're gonna install Axios, Bec32, Cores, and Crypto. So I'll open up my terminal here, and let me zoom in for you all. Sweet. Okay. Just paste that. It should install everything. All right. And let's go ahead. Let's just run this one time and just make sure we haven't broken anything so far. So we can do npm run dev. This will run it on a local server, localhost 3000. So I can open this up in the browser. And internet's being slow. Okay, cool. So this is just kind of the standard out-of-the-box NextJS app that you get. You know, they just point you in the direction of the docs and everything. But none of this matters because we actually don't need a front end. We're going to be hosting this as a server, first and foremost. So cool, that looks good. Now we're going to create our project structure. So this is what your file tree should look like at the end when we create a project structure. I know this looks like a lot, but really it's just these 1, 2, 3, 4, 5, 6. These 6 things that you need to add. And we're just going to create these folders and these files, and we're going to leave them empty for right now. And we're going to step through and we're going to add the code into each one. But you can already see right away, or guess a little bit of what might be happening here. You know, we have a callback endpoint. It's going to exist. This is going to be our callback for LNURL. We have our LNURL-P, which is going to be for our Lightning address. We're going to have an endpoint to get our just raw LNURL, right? So this will just be LUD1. And then an endpoint to create LNURL. And then this lnd.js is going to store our information that's, well, really, it's where we're going to set up our connection to our Lightning node. So let's go in and out of all this stuff. We'll take a second. First of all, I'm just going to delete this hello. This is just an example endpoint. Move to trash. So I'm going to create a callback folder first and foremost. Then I'm going to create an LNURL-P folder. Then we've got lnd.js we're going to add here. I've got lnurl.js. And then I've got get lnurl.js. Okay, cool, that looks right. And then inside of the callback in the lnurl folders here, I'm going to add a funny file that's called slug. And it's surrounded by brackets like this, slug.js. This just means this is a placeholder, meaning that we don't know what the user's Lightning address name is going to be. So this placeholder allows us to kind of listen and expect any different name to come through and then handle it appropriately. So I'll add one here as well, slug.js. Okay, and something important that I have not explained yet about NextJS and kind of how this API folder works is this is called, what is this called? Dynamic routing? I forget what it's called exactly, the technical term, but essentially what happens under this API folder, everything that gets added under it becomes a /route. So for example, when we call callback, we're going to call /API /callback /username, right? So these are nested inside of each other. So the structure of this folder actually defines what our URL scheme is going to be. And so that's really important. You know, these have to be in the correct place. And it's actually a nice feature, because normally you have to build this stuff very manually with a router yourself. And it just kind of comes out of the box with NextJS. We just have to put it in the right order. But this is all in the right order. And we have two other things to add here. Actually, no, one other thing. We need to add utils folder with /middleware file. And this is just going to be in the root of our project, so it's not going to be inside of the API. So I can go here, new folder. What did I say? Utils. And then inside of utils, we're going to have middleware.js. Okay. I know this is a lot. We're just setting all this up, but don't worry, this will make things easier in the end. It's like our structure is in place, and we're going to systematically implement the LNURL spec and add all of our code in, piece by piece. So with all of that set up, next we actually need to do a few boring things, a few just configuration things that are going to be required for us to follow the spec and to deal with having a server that's live. So the boring stuff we need to do is we need to set up what's called CORS middleware. And CORS stands for Cross-Origin Resource Sharing. It's just a format that you need to put on your endpoints to show kind of what and how you're supposed to be able to share information over an API. That's kind of a terrible explanation. Let's Google it, see what Google says. What is CORS? So, HTTP header based mechanism that allows a server to indicate any origins, domain, scheme, or port other than its own from which a browser should permit loading resources. So it's basically just restricting who can get resources from me, who can post resources to me, and you know, what are the details of those as far as the domain, the scheme, the port. So CORS is normally, it's not exciting. It's normally something that stops us and it becomes a blocker as web developers, but we're just going to create some CORS middleware that's essentially going to let anyone request invoices from us. That's all we're going to do. So that's the boring thing number one. Boring thing number two is we need to set up something called rewrites in nextconfig.js, which will let us reconfigure a few of our routes so that we adhere to the LUD16 spec. So what do I mean by that? So back to our routes. So remember I was talking about, you know, we've got /API, /callback, you know, /username or something like that. So that's how our routes are set up, but if we look at the spec for lightning address, we need to have this domain.com /.wellknown. We need to have this funny looking well-known thing inside of one of our routes. So instead of making a folder that lays this out exactly, we can actually do something called a rewrite that will just reconfigure the order of that and allow us to adhere to the spec and have this, you know, domain.com /wellknown /lnurlp /username. So simple as that. So those are the boring things, so let's add them in. First we have the CORS middleware here. We're going to copy this and add it into utils /middleware.js. So I'm going to grab all of this and copy it. Okay, looks good. And then our rewrites are going to live in next.config.js. Let's copy this. And so this is right here, nextconfig. It's just the configuration for a Next.js project. So every project will come with it, and it comes basically empty at the start. So we can just, you know, paste over everything, and then our rewrites are here. And we can see that what we're saying here is we're saying that this destination /API /lnurlp /slug, we want to rewrite it to be .wellknown lnurlp @slug. Okay, so pretty simple. So we're just, you know, manipulating it to follow the spec without having to write some janky code inside of our folders here. Great. Save that, and usually when you change your next config, you need to restart your server, or it'll force you to do that. So I'll run npm run dev again. And we don't need to be running it yet right now. Okay. Cool. So that's our first little bit of code added. And I'll just throw this in one more time. If you're joining us right now, this is where you can find the slides to be able to follow along. It has all the code. So tinyurl.com/lightning address workshop right here. You know, burn it into your retinas, and then this is the final project I have, which you'll be able to access once you get to the slides. Okay, cool. So we added our first bits of boring code here, but this is out of the way. And now we can focus on what we're really here to do, which is implement LNURL and then lightning address on top of it. So let's implement the LUD01 and LUD6 spec. So these are the base specs that lightning address is dependent on. So we have our API/LNURL.js. That file already exists. We're going to take this code and I'm going to paste it in there. And I'm going to walk through this code for you. What was that? LNURL? Yeah, okay. Okay, cool. So here's what is happening. So we now see the spec is starting to come to life. So first of all, at the top, we're just defining a handler. So that just means, you know, we're handling this API route. So we're expecting any requests that come in, and we'll be able to respond to those requests like we do down here at the bottom. That's what rec and res stand for. At the start, we run our cores middleware here, which will just let anyone request invoices from us. And then this is where we make that response object that is defined in the LNURL spec. So we have the metadata right here. We're just following the format that's on the LUD document. You can go review it again yourself. And I'm just putting my description as, you know, sample LN address endpoint. We've got our callback defined here, which is going to have an environment variable that we'll add in a minute. And my callback is actually API/callback. Look at this. It says /Bitcoin Plebdev. So this is one thing that you will want to change on your side. Bitcoin Plebdev is what's going to be my username of my lightning address. But whatever yours is, you know, you're going to want to put it here. So if it's like pleb lord 420, you know, that's what you would put. And there will be one other place that you'll change that. But I'm keeping mine as Bitcoin Plebdev. And right, so this is like once we go into the callback, then we go into slug. And of course, slug is just a placeholder. It can be anything. So slug will actually be listening for my lightning address specifically. Okay, so that'll make a little more sense once we get to the callback endpoint. I've got a max sendable and a min sendable. So this is in the millisatoshis format, so it's basically this 1000 is actually 1 sat. And then this is, I have no idea, what is that, 100,000 sats maybe? I think so. So that's my max sendable is 100,000 sats, which is probably good max. You know, I don't want someone to drain all my liquidity. Actually, I kind of do. If they're paying me, that would be kind of cool. So, so you could raise this if you want. You can throw a few more zeros on there. Okay, and then we've got our tag, of course, which is pay request. And then we're putting in our metadata, and we just have to put it in this JSON stringify format. Okay, cool. So that's our LNURL endpoint. So here, you know, we're just creating the structure of an object that follows the spec. You know, that's all it is. We haven't done any fancy programming yet. We just create this, and then we send it back when someone requests it. Okay, so that was LNURL.js. Now let's fill in our get LNURL.js. So what this is doing here is, once again, let's start with the handler. We have our handler for the API endpoint. we run our middleware just like last time, and we take this original URL and we encode it in this Bec32 format, and we just return it. That's it, right? You know, the spec said that, you know, what is LNURL? It is a server endpoint that is Bec32 encoded. And then when you request that Bec32 encoded endpoint /LNURL, we expect that we'll get back this object. So that is exactly what we're doing for them. So this is where we'll be able to get our LNURL. We're using the Bec32 library here to just do the encoding. I know this looks a little bit funny, but you know, we have to turn it into basically into words first. This buffer format, UTF-8, and then we encode it with LNURL at the beginning, a certain length, and we're just going to turn it all into uppercase. So this is code, you know, this is code that I think this is even in the LNURL spec as like an example of how you encode in LNURL. So I know maybe it looks complicated, but we're just encoding as Bec32 here. Cool. So that is LNURL and get LNURL. Okay, so now let's set up the connection to our Lightning node. And we'll start to test stuff a little bit later. We don't have quite enough to start testing yet. So what I'm going to be using is a tool called Polar and ngrok locally for my Lightning Network kind of environment. And then I'm going to be using my Voltage node in production at the end of this workshop. So I'm going to be using my real node at the very end. So what is Polar and ngrok? I talk about Polar probably almost every workshop, because this is just what I use as a local Lightning Network development environment. It's very simple. So what do you need to run Polar? You need Docker Desktop. It's a very standard software that basically it containerizes, packages up full software projects in an environment that stays a little bit separate from your operating system. And that's what Polar runs on top of. And Polar is an entire local fake Bitcoin network and Lightning network that we're going to use to test and run everything. So you can find the links to those here. And yeah, I've got everything installed, but I'd kind of show you what you do here. We open Docker Desktop, wait for it to start. We open Polar, create a Lightning network. We're going to give it a name and all of that, and then we're going to start it up. So let's see what that looks like. So I'm going to go find Docker, open Docker. This will take a second to kind of spin up. You know, once again, feel free to throw any questions you have into the chat. And I think I have the live chat up. Yeah, Docker can take a minute to start up sometime. While I have this moment though, you know, I want to tell you something really cool that I think I've realized through this workshop, which should be obvious, is that, you know, Lightning address is this thing that most people, they only have it through a custodial wallet. But the reality is, once you build an LNURL and a Lightning address server, you realize that you could provide Lightning addresses for anyone in the world, and all they would have to give you is their invoice key to their node. So they would need to be able to be running a Lightning node, and then they'd need to give you this invoice key. And all this invoice key lets you do is pay them, right? So it's not like you're giving up control of your node. So that's a really cool thing. So something I would like to do with this workshop is actually evolve it into something a little more sophisticated and simple to use, to where anyone that's non-technical, if they were running a Lightning node, they could just put in these few variables and then instantly be running their own Lightning server. So they don't need to rely on Wallet of Satoshi or Alby or anyone else like that, that they could self-host their own. And so that's a cool thing I would like to do in the future. And it's just a cool thing that you'll be able to do once you have this server built. I mean, we're kind of going to build this just for our one Lightning address username right now. but it could easily be extended to kind of let you plug in your friends' Lightning address servers. And of course, us hosting it on Vercel as well, you can put in your own custom domain. So if you have a cool, a cool domain that you're hodling, pleblord.com or something, you can be, Austin at pleblord.com, and you can make that happen all for free for Vercel. So that's pretty sweet. Okay, so Docker took freaking forever, but it is running now. So now I can open up Polar, and we can create a little local Lightning Network environment. Sweet, so I deleted everything, so this is just all from scratch. I'm gonna say create Lightning Network. I'm gonna give it a name. I'll call it ln-address, I suppose. And I'm gonna give it 3 LND nodes, because we're just gonna be using LND just to keep things simple right now. And then I'll empty out the core Lightning in the eclair field. And then of course we're gonna have a Bitcoin core node because all Lightning nodes run on top of Bitcoin. So we're gonna need that Bitcoin node. And here we go. So gives me this screen. I've got this beautiful UI to interact with my nodes. I can hit start, and we are gonna start a new fake Bitcoin blockchain from block height 0 that only exists on our local machine. And I'm just gonna do a basic setup for these Lightning nodes. Right, so we see that these Lightning nodes, they're built on top of, they're dependent on the Bitcoin core node. And we can click into them and do actions on them, and then we also have connection info. So I'm gonna go into Alice here. I always choose Alice as my node. And I'm gonna open a channel to Bob for 250,000 sats. So when I do this, it's actually going to mine a bunch of blocks, give me the block reward, put it into my wallet, open the so it does a lot of things in the background just to let us do these simple actions and abstract it and make it easy. And then in the end, what's going to happen, we're going to be at block height 101 or something like that, maybe 111. And then we're going to have an open Lightning channel of 250,000 sats. So we'll give it a second. It's usually slow the first time. Okay, there we are. We're at block height 113. We've got a channel open to Bob. Now let's have Bob open a channel to us. We'll do outgoing from Bob to Alice, and then deposit enough funds for Bob to open the channel. Okay, there we go. And this way we'll have, a little bit of a Lightning network. We'll be able to send and receive, at least between Bob and Alice. And we're going to be acting as Alice. Alice is going to be our node. Okay, great. So everything is set up here. So let's go back to the slides. So we started it up. And so now we're going to create these environment variables that we've set aside. And there's going to be 3 of them. 1 for our LND host, 1 for our LND macaroon, and then 1 for backend URL. And I'll walk through what these mean. So we're going to grab the REST endpoint for your node. This is inside of Polar. So if I go into Polar, I'm on Alice, I'm on the Connect tab. I can see this thing that says REST host. I know this might be a little small on your guys' side. Let me see. Can I zoom in? I cannot zoom in. Okay. Well, but it's right here, REST host, and I can just copy this. And it's just a really simple endpoint. So I'm going to go ahead and create new file .env, and we'll call this lnd_host all caps equals this. Cool. And then we're gonna have our LND macaroon. So we're gonna grab our hex encoded invoice macaroon. So like I was saying earlier, we don't need to give the server full admin permissions to our node. We only need to give them what's called invoice permissions, which is just the ability to request invoices from us. So if I go down here into Polar, there's more connection info over here. I jump to the hex tab, and I can see there's an invoice macaroon. So I'm going to copy that. It's going to be this huge blob of hex, and we'll put it in as lnd_macaroon equals, boom, Okay. Normally, if this was my real node, I might not want to show. Well, I guess it wouldn't matter because it's my invoice macaroon, but you know, be careful with your macaroons. Okay, and then the final environment variable we're gonna have is backend URL, which right now we're just gonna set to localhost 3000 because that's where we're running. We're running locally. Backend URL. Did I spell that wrong? No. Okay. http://localhost 3000. Oh, equals. Okay, cool. So all of that should be in place. I'm just going to restart my server just to make sure it does reload these environment variables. In case you don't know what environment variables are, these are just a way for us to store secrets in our project. That our project needs to use these secrets in order to run, but we don't want to dox them to the whole world. So we use .env files and what we call environment variables to kind of handle that. Great, so we added this. So now we can create the LND endpoint, which will call our node for invoices. So now with just this little bit of code right here, we're going to connect to our Lightning node. And I'll walk through it. Let's just paste it in first. And that's an lnd.js. Cool. So, what is happening here? So we're importing a library to make HTTP requests at the top. You can see we're grabbing our LND host and our LND macaroon. We have to grab it through this process.env. You know, since we're trying to keep these secret, this is just sort of the process that we have to use to grab them inside of our project. Because you can think of these environment variables, they get kind of stored separately in kind of a secure enclave. And they can only get accessed in this way through the project. So we have our handler here. This is just like our other handlers. And then a try catch. So we're going to try an operation, and if it doesn't work out, we're going to catch an error. So inside of our try, we're calling the REST interface of our LND node. Right? Remember that variable that we copied right here, REST host. So that is basically the IP address of our LND node, which we have saved in the environment variables. And we're going to call the interface for it, /v1/invoices. That's where you call to grab invoices. And we're passing in these values. So we have the value of the invoice and the description hash, which we talked about a little bit with the spec. We'll go over that slightly more. And in our header, we have to put this gRPC metadata macaroon. And we put our LND macaroon in there. What this is basically doing is this is kind of our authorization to talk to our node. Because we're not just letting anyone talk to our node. We're letting anyone get invoices through us, but only our server is the one that's talking to our own node. Right? So this is kind of just the password that we use to be able to talk to our own node. And then we'll pass invoices to the user. Like, you're not going to connect to my node. I'm just going to pass you the invoice from my own server. That's kind of what's happening. So right here we have this HTTPS agent, and that's what's being defined up here. This is just something dumb that we have to do while we're in local development to disable the SSL verification for the LND cert locally. And we're going to remove this in production. This just has to do, similar with when we were talking about cores, this just has to do with the format of how you need to request resources from a Lightning node. Normally we have to set up this SSL verification, and we just don't really want to do that right now, so we're just disabling it locally. And then in production, Vercel is actually going to set that up for us, so we're not even going to have to worry about that. But I just want to explain this to you so you know it's not confusing. So yeah, so we make the request, and then we get the response from our node. And response.data.paymentRequest should house the invoice. And we simply just return that. Or we catch and we return an error. Okay, cool. So that is our connection to our Lightning node. It's a one-way street. we just ask for invoices, that's it, and then we pass them back. Cool. So we've gone through our boring setup, our boring prerequisite things. We've done our LUD1 and LUD6 implementation. We still haven't fully tested it, but it's in place. And now we have our connection to our Lightning node. So what comes next is the two most important endpoints, our callback endpoint, which is going to complete the pay spec, and then our LNURL-P endpoint, which is going to complete the Lightning address spec. So the callback endpoint is what both our LNURL-Pay and Lightning address endpoints will use to pass the invoice to the requester. Okay, so we'll see that in action here. Got a question in the chat. It seems like you're pretty good at your craft. What's your background been? How long have you been coding for? Did you take a CS degree? Great questions. Yeah, I mean, I do not have a CS degree. I went to boot camp actually, and a little bit of the School of Hard Knocks, doing a lot of experiments and making a lot of bad code. I've been coding for about almost 5 years now. So honestly, I had a pretty slow journey. It wasn't until about a year and a half ago that I really started to ramp up in my skills. And a lot of it had to do with just getting help from people in the Bitcoin community, other Bitcoin developers. So that's what helped me a lot. And really that's what I'm trying to do here, is like pass back that information that's helped me so much. But you know, it all just comes back to the web development fundamentals, which this is exactly what we cover in our first Plebdevs course, which you can find here at plebdevs.com. And so in our first course here, I just tried to like cut through all of the crap and show you exactly what took me from zero to being able to build simple apps. And it took me 3 years, and me and my friend Super Testnet, we tried to boil it down into a simple possible course that will just show you the minimum amount that you need to start getting your hands dirty. So yeah, I mean, either way it takes proof of work, but gosh, it is so much easier when you've got people to show you kind of great tools to use, the best path, tips, tricks, all of that, or just help you get unblocked from a bug. And so this is a lot of what I'm trying to do with Plebdevs. So definitely, like, thanks for joining, and would love to hear more about like your path and what you're trying to do, because I definitely relate to you all. I don't feel like much of a software engineer, or at least it took a really long time for me to get there. So it's cool to bring more people along. Okay, so callback and LNURL-P endpoints. So this is going to be, once again, the completion of our LNURL-Pay spec, and then the Lightning address. But really, these are both just the same things, right? It's just this format that we're going to follow to request invoices from our node. That's it. So we have /callback/slug that we're going to put in here. This is the biggest file of code. Let's just copy this. I'm going to walk through it for you. So callback/slug. And once again, the slug here, this is just a placeholder for a username that we don't know what that username is. We're just ready for any username. Cool. So we're doing our imports. This looks a little bit like our other routes. I'm pulling in my backend URL. We've got our handler, and I'm running the middleware. And then we get into the logic. All right. So I'm able to get the slug, meaning I'm able to get what username did the user pass us. But me, you see right here, I'm only looking for slug equals Bitcoin Plebdev, because this is my username that I want to add for my Lightning address. So once again, if you're pleb, I don't know where pleblord 420 came from, but that's my like placeholder. If you're pleblord, this is what you would put here. I'm putting Bitcoin Plebdev, and then once again we have in our LNURL, we have Bitcoin Plebdev hard coded right here. So that's just a little shortcut we're doing right now, because we're just making this Lightning address for ourselves at the moment. But you can very easily extend this to house hundreds and thousands of Lightning addresses for your friends or your fake Noster pub keys. Cool. So if this is me, if this is Bitcoin Plebdev, and if there's an amount attached, because remember, this is our callback endpoint, and according to the spec, when we hit the callback, it needs to be with an amount. So we just check those two things up front, and if we have that, we start to put together this request for an invoice. Okay, so this is the confusing part right here, is the description hash. So before we walk through this, let's just jump back to the spec one more time. Back to LUD 06. And okay, and so we have the metadata, right? We know that just says, you know, sample LN address endpoint. It's just, you know, basic information, metadata about the server that we're hosting. But what we actually need to do, where is that? Okay, so after the wallet is trying to tip us, is trying to pay us. After it grabs the invoice from us, it verifies that the H tag in the provided invoice is a hash of metadata, string converted into a byte array. So what this really means is we have this metadata that's like, hey, this is my LNURL endpoint, but we actually use that metadata and pass it into the invoice and kind of encrypt it into the invoice. So that way, when the user gets back the invoice, they know it's coming from us, and they can verify that hash. And so this is the one little piece where the wallet that's paying and then the LNURL server, they're trying not to trust each other. They're trying to verify. And so that's exactly what's happening here in this callback endpoint, right? So we make our metadata. It's just the same as, you know, right here. This is like our basic spec, our basic object, and we have our metadata here. So we take that, we stringify it, we hash it with SHA-256 into a hex format, and then we turn that into base 64. So I know this is a little bit confusing. Once again, it's always the encryption stuff, but this is example code that you can find probably in the LNURL spec, and this is just the steps that we need to do because we're starting with this metadata, and what we need to end with is a hash in the format of base 64 of that metadata. So we first have to turn it into hex, and then from hex we're able to turn it into base 64. I know that's kind of funny looking, but you know, really all you need to know is like we're encrypting the metadata, it's becoming the description hash, and this we're actually passing it into our node for the creation of each invoice. Okay? So what am I doing here? So we make the description hash, we grab the value of how much the person wants to pay us, and we just check here real quick. We just make sure that, you know, if it's less than 1, then, you know, we're not going to accept that. It has to be at least 1 Satoshi. And we have to convert it from Satoshis to Satoshis. So otherwise, we call our own API, L&D, right? We call this endpoint, which then calls our Lightning node to grab the invoice. Does that make sense? Right? So when we call this, we're passing in the amount, and then we're passing in the description hash. And L&D, it takes that description hash and it kind of just bakes it into the invoice. And then we expect an invoice back, and we send that back to the user that requested it. Okay? So we'll see this in action. It'll make more sense, as always, once your hands are dirty. Okay, cool. So that's a callback endpoint. This is the biggest endpoint. Let me know if there's anything in here you want me to go over again. Back to the slides. I think we just have one more endpoint to build here. Yes, this is an LNURL P endpoint for our Lightning address. Let's copy this and go back. Okay, cool. So starting to look pretty similar. We're not doing anything crazy new in a lot of these endpoints. A lot of them are similar, and we're really just trying to adhere to the spec. So I've got my handler. I run my middleware. Uh, we grab the slug, and once again, I make sure this is Bitcoin Plebdev, because I'm only supporting this for my own Lightning address at the moment. And then we kind of just send back this standard object. I mean, that's really it, and we tell them where our callback is, and once they call that callback, they'll get the invoice. In theory, that's how it works. Okay, so now we have all of that in place. So, in order to test this, we need to set up in Grok if we're going to test it locally. If you are... so you don't necessarily need to do this if you're going to deploy it, if you're using a real node. But this just runs into the problem, well, like exactly what it says here. This allows us to take our local host and broadcast it on a temporary global host. So, you know, since we're running everything locally right now, if we try and interact with like a, you know, a wallet that scans an LNURL code, it doesn't know where localhost 3000 is. So we need to have a global host that it can talk to. Okay, so that's what we're gonna do right here. I apologize if this is confusing. I know we have to use a lot of tools, but you know, like I said before, I end up using the same 4 to 6 tools all the time. Ngrok and Polar are 2 big ones. So you'll see these again and again in my workshops. But what we're going to do is you might need to install Ngrok first. I already have it installed. We're going to start our server. And then we are going to say Ngrok HTTP, our local host, and then it will give us back a global host, and we're going to update our backend URL with that global host. Okay, so let's do that. So I'm going to go here, and I'm going to say npx ngrok http local host 3000. Uh-oh. Alright, y'all. I am recording this after the fact just to splice this in and finish this workshop clean. Had some technical difficulties, to say the least. Our memory overflowed and things started grinding to a halt. But I remembered exactly where we were, so I just want to start here, and we'll continue and finish this workshop. Cool. So, we were talking about Ngrok. We talked about why we need Ngrok just to test our setup locally here still. So, yeah, we just need to take our local host, we need to make it a global host, and this is because we're going to try and interact with basically a Lightning decoder that it needs to call our endpoint, so it needs to have a global host that it can call, and that will just help us check the LNURL spec, check that we follow that spec correctly and everything looks good. And then I'm just going to hit the callback endpoint to check that we can get an invoice, right? So let's do this. So we have the server is here locally. I removed that for a second, but I'm just going to npm run dev, run it like we were before, okay, on localhost 3000. Great. Okay, so now I should be able to run this command. npx ngrok http localhost 3000. Okay, cool. So if I make this a little bit bigger, we can see that this is forwarding to our local host. So this is the temporary global host it's giving us here. So I'm going to copy this, and I can actually, I can visit it, and I'll see that this is just our basic, boilerplate NextJS app that we have here. But I'm going to add this as our new backend URL in the environment variables here. And we'll just go ahead and restart and run that. Okay, so now we have a global host. So what that means I can do is I can go here to /API/get LNURL. Okay, and so this will get us our Beck32 encoded LNURL, and we can actually take this into lightningdecoder.com. Let me back out of this. And we can paste in invoices, lightning address, LN URL, and this is a cool tool that just helps us decode it. But this will actually help us verify that, that it's live, that the format is correct, and everything like that. So we should see our our response object. Okay, great. So we have our callback URL right here. We have our max sendable, min sendable. That's our description, and then of course our tag of pay request, since that's the only feature we support. So I'm going to copy this link, and I'm going to open this up in a new tab. So this is our callback, and I just need to put $amount equals whatever. I'm going to put 1,000, because remember this is millisats, so that 1,000 is actually going to be 1 Satoshi. So if we go here, I should get an invoice that is payable by Bob, right? So this should be Alice's invoice. Awesome. Yes, big ol' invoice here for Alice. Let's see if we can go make Bob pay this. So pay invoice for Bob. I paste this in. Okay, great. So from what we can test so far, at least, our callback endpoint is working, so we're talking to our Lightning node correctly. We seem to be adhering to the LNURL spec. It's decoding properly. But now I want to test this with my real node, and I want to test it with a real Lightning wallet. I want to be able to pay my Lightning address server from my Stacker News wallet. So for the final step of that, we need to get into the actual deployment. So things look good so far. We just had to do this in Grok just to, test things locally before we push right to prod, which is, a pretty nice thing to do. Oh yeah, and we did this, so we did get LNURL, Lightning decoder. Oh, and yeah, we can call our Lightning address endpoint too. We should probably do that. And so that should be our URL /.well known /lnurlp, and then our username, which is Bitcoin Plebdev, and this should just give us back like the standard response, right? Yeah, cool. And it has the callback and min sendable, max sendable, metadata, and the tag. Sweet. Okay, so everything working locally, and we got an invoice that is payable from Bob. Okay, so now we can go to deploy on Vercel. So if you've never used Vercel before, it's super easy. Go to vercel.com. You can log in and connect. Oh, I already have this deployed already. Let me actually take it down. I was doing that just for a test. Okay, cool. So you go to the home page, and we can do add new and add new project. And if we go here, it's pulling from our GitHub, so it should find the Lightning address workshop is my most recent one. So I can import this, and the defaults here for everything are good except for the environment variables. We need to put on our environment variables because we have them locally, but once we move to the production environment, the remote environment, we need to add them again. And Vercel is basically going to encrypt and store these and keep them secure for us. So first of all, I'm going to put in the backend URL. And so I already know what this is going to be just because of how Vercel makes basically like example domains for you off of your project name. So since my project name is Lightning Address Workshop, I know that my backend URL is going to be / Lightning Address Workshop.vercel.app. Cool. So that looks good. We're then going to have our LND host, and I'm going to get this from Voltage now, right? So I'm going to be using my real Lightning node. So if you go to Voltage, this is the home page of your node, And you can go into the connect settings, and under connect you'll find the manual option, and the manual option will have your host. Let me see if I can actually, like, I don't want to dox my real credentials here, so let me just make sure that I can visit this without doing that. I cannot. Okay. But either way, you go to connect, and there's a drop down. You select manual on that drop down, and you get an API endpoint. And so let me grab this and pull this over. So this is the API endpoint it gave me for my specific voltage node, and I'm just going to throw an HTTPS in front of that. Okay, and that should be good. So add that. And next we have our LND underscore macaroon. And remember, this just needs to be an invoice macaroon. So on my connect page, I'm scrolling down here, and I see a little option for, bake invoice macaroon. And that's just their fancy way of saying just make a new invoice macaroon. So I'll do that, and then I can grab the hex version of it and bring it over here, and I paste it in, and that all looks good. Sweet. So we have our macaroon, our host, and our backend URL. So let's deploy it. Let's see if this works. Take about 30 seconds to deploy. And yeah, once again, once you have this project spun up, it's really, really easy. If you have maybe bought a domain from Namecheap or GoDaddy or something like that, you can add your custom domain to Vercel very easily. So, that makes it cool. If you got your vanity domain, you can now have your vanity lightning address. So I'll probably do that at some point. I want to have I have plebdevs.com, so I want to have Austin at plebdevs.com as my lightning address. And so that's really going to be really easy to actually add to my already existing plebdevs.com, since it's a NextJS project, and everything we're doing here is on the API side. Okay, so our project is deployed now, so I can go to that main deployment. Looks good. So let's start again by kind of doing the same steps. I'm going to do API / get ln URL. We should get that again. Okay, cool. And back to Lightning Decoder. Can X this out. We should see the same info. Yep, just our updated callback URL. Okay, all that looks good. And once again, if I copy this link, I should be able to add an amount on the end of it. And we get an invoice back. Sweet. Okay, so that seems to work. So that was our ln URL. And now we want to test the final part, the lightning address. So I'm going to go to my wallet here on Stacker News. Close this out. Go to withdraw. No, thank you. And I can go to lightning address. And I'm going to send myself 11 sats here. So it should be Bitcoin plebdev at lightning address workshop.vercel.app. Not a very good lightning address right now, right? Not very memorable. But this is just our placeholder. It's live, and we can easily switch out the domain. But okay, let's see if we get this payment. And I'm going to go over here, and I'm going to open up my wallet. And I'm going to verify that we're getting it. Taking a second here. Okay, it says sent 11 sats with 0 sats and routing fees. That's pretty nice. I actually have a channel with Stacker News, so that should probably be where it went through. And I'm loading up my Zeus wallet. And it's not loading. But, I mean, we can... Okay, here we go. So, activity, recent, and there we have it. I don't know if you can see it, but at the very top, I've got 11 sats received over Lightning. January 6th, 4:04 p.m. Sweet. So we now have a live Lightning address. We built it from scratch in about an hour and a half. You know, with uh, with our fair bit of work and maybe a little bit of trouble, but we built it nonetheless, and it is working. And we have it hosted for free, essentially forever, right? And we can switch out the domains. Um, right now, it's set up just, of course, for only our one Lightning address, but you can easily set it up to connect to your friends' nodes or something like that, and you can do it in such a way to where you can't rug them, you can't steal their money, because we're using the invoice macaroon. So that I think that is it. So yeah, we walk through the steps: deploy, production environment variables, click deploy, and then we went through our test steps one more time. So that is everything I wanted to cover. Sorry about the trouble in the live stream, but I'm gonna go ahead and put these videos together, and it seems that everything works. I hope you're able to go through this and build your own Lightning address server, and of course, hit me up if you have any trouble, if you have questions. I'd love to help you out and just continue to build on this material and improve it. So, thanks for showing up, thanks for watching, and until next time, it's freaking Plebdevs, baby. Let's go.